Hello, we're going to look at J6, which is solving equations with variables on both sides. Nothing about our process is going to change. We're just adding another layer. Where before we had either to combine like terms and we had numbers on one side or the other, this time we have variables on both sides of the equal sign, and our task is to get the variable term on one side of the equal sign and the number term on the other side of the equal sign. This can be accomplished in a couple of ways, but two ways that I'm going to discuss with you today are just moving from left to right, which may require that we have to divide at the end by a negative number, but that's okay. Or thinking about it to where I want all of my variables to be positive so that I don't have to divide by a negative number. So let's go ahead and move left to right first. So that means since I have a variable over on the right side, I'm going to go ahead and move my 6f over to this variable. So I'm going to move, by applying opposite operations, the 6f. I'm going to add 6f to both sides of the equation, and that leaves me with negative 10 is equal to, well, 8 has the advantage and it's negative by 2, so this would be negative 2f. Then I would divide by negative 2 on both sides of the equation. Negative 2f divided by negative 2 leaves me positive f, and negative 10 divided by 2 leaves me positive 5. That's one way to do it. Or you could do the following. I'm going to write it as it appears. Now, negative 8, the absolute value of negative 8 is 8, because negative 8 is 8 spaces from 0 on the number line. So I know that if I add 8f to both sides of the equation, that I will have negative 10. Now 8 has the advantage and it's positive by 2. But over here I have 0. Well, now that I have 2f, I don't want this numeric term and algebraic term on the same side of the equal sign. I need to move the numeric term. So I'm going to add 10 to both sides of the equation, and I'm left with 2f is equal to positive 10, and I still divide by 2 on both sides of the equation. 2f divided by 2 leaves me positive 1f, and 10 divided by 2 leaves me 5. So either way is fine. Next, for number 2, we have negative 6j is equal to 9 minus 3j. So again, I could either just add 3j to both sides of the equation, and that leaves me, well, negative 6 has the advantage by 3, so negative 3j equals 9, divided by negative 3 on both sides of the equation. J is equal to positive 9 divided by negative 3 is negative 3, or I have negative 6j equals 9 minus 3j. I know that the absolute value of negative 6 is 6, so if I move that to the right side, it's going to create a positive algebraic term. So that leaves me 0 is equal to 9 plus 3j. I don't want the numeric and the algebraic term on the same side, so I'm going to subtract 9 from both sides of the equation. That leaves me 3j is equal to negative 9. I'm going to divide by 3 on both sides of the equation, and that gives me negative 3 is equal to j. For number 3, I have 9h is equal to 6 plus 7h. Well, here I can just move the 7. So minus 7h minus 7h on both sides of the equal sign. 9h minus 7h leaves me 2h equals 6. Divide by 2 on both sides of the equation. H is equal to 3. For number 4, we have 9m is equal to 10 plus 10m. Well, 10 is larger and 9 is smaller, so I'm going to move the 9m. Remember what this is called? Hopefully you said additive inverse pair, and you would be right. So that gives me 0 is equal to 10 plus 10 minus 9 is 1m. So you could either write m or 1m. I don't want the numeric and algebraic term on the same side of the equal sign because I'm trying to get m alone. So I'm going to subtract 10 from both sides of the equal sign, and I'm left with m is equal to negative 10. So here we have number 5, which is 7u is equal to negative 9 plus 10u. 7 is smaller than 10, so I'm going to move the 7 by subtracting 7u from both sides of the equation. That leaves me with 0 equals negative 9 plus 3u. And I want to isolate u, so therefore I'm going to add 9 to both sides of the equation. And I have 9 is equal to 3 multiplied by u. I'm going to divide by 3 on both sides of the equation, and that gives me u is equal to 3. Number 6, negative 2v minus 10 equals 3v plus 5. Now, this might seem like, oh my gosh, they added another something. Process is the same, guys. We're just trying to get the variable term on one side of the equal sign and the numeric term on the other. Well, here 3v is positive and 2 is negative, and I want to keep my terms positive, so I'm going to add 2v to both sides of the equation, and that leaves me negative 10 is equal to 5v plus 5. So I'm already done with the variable term or algebraic term. Now here's my hint for you. When you have multiple terms, once you get down to one algebraic or one numeric term, do not continue to move it back and forth. So like, oh, I have 5v, I'm going to put it over here. No, I don't want it over here. Put it over there. No, I don't want it. So since I have just one algebraic term, I'm not going to touch it anymore. Now I'm going to deal with the numeric terms. So I'm going to subtract 5 from both sides of the equation. And that leaves me with 5v is equal to negative 15. Divide by 5 on both sides of the equation, and that gives me v is equal to negative 3. Now, if you notice, we have negative 6q on the left side of the equal sign, and that equals negative 3 minus 5q. Well, the 5 is smaller than the 6, so I'm going to add 6q to both sides of the equation. And that leaves me negative 6q plus 6q is 0, equals negative 3. And we're looking at who has the advantage. 6 has the advantage by 1, and it's positive, so this is going to be 1q, or just q. And we need to move the 3 to the other side, so we're going to add 3 to both sides of the equation. And that leaves us with 3 is equal to 1q, or 3 is equal to q.
Times 5.
Don't listen to him. That was my husband. Let's do 8. So we have 6y plus 4 equals 2y. I know you guys wanted me to say it. Don't come for me. Honey, don't come for me. All right.
I already have you.
Yes, he does. All right, so we've got 6y plus 4 equals 2y. Again, we want all the variables on one side of the equal sign and the numbers on the other. Well, 2 is smaller than 6, so we're going to subtract 2y from both sides of the equation. So 6y minus 2y is 4y, plus 4 equals 0. Well, since we have the 4y over here, we're going to move the positive 4 to the other side. We do that by subtracting 4 from both sides of the equation. 4y is equal to negative 4. 4 multiplied by y, we're going to divide by 4 on both sides of the equation. 4y divided by 4 leaves us positive y, and negative 4 divided by 4 leaves us negative 1. Alright, with number 8, we have several things going on. So what we're going to do is simplify the right side of the equation prior to applying inverse operations, meaning opposite operations, to isolate the variable or to get the variable alone. So you notice here we have two numeric terms. We can put those together. So it's negative 4u minus 1 is equal to negative 6u. 9 plus 10 is positive 19. So now we're at a place where we can begin to move the variable to the other side of the equal sign. And we're going to do that by creating our additive inverse pair. So we're going to add 6u to the right side, add 6u to the left side. And we have negative 4u plus 6u. Well, 6 has the advantage by 2. So it's positive 2u minus 1 equals 19. We're going to add 1 to both sides of the equation. So we have 2u is equal to 20. We divide by 2 on both sides of the equation. Therefore, u is equal to 10. Number 9 is negative r minus 8 equals 2r minus 8. And the 2 is larger than negative 1, so we're going to add 1r to both sides of the equation. And we're left with negative 8 is equal to 2r plus another r is 3r. And then we have minus 8. Well, here we're going to add 8 to both sides of the equation. And we're left with 0 is equal to 3 multiplied by r. Well, if I want r alone, I'm going to divide by 3 on both sides of the equation. 3r divided by 3 is equal to 1r, or just r. 0 divided by 3 is 0. And that's a good note to have. Actually, any number that you try to divide into 0 is always going to yield 0.
Nothing from nothing, leave nothing.
Thank you for that rendition. All right. So we have number 10 is negative 7 minus c is equal to 3c plus 5. Now, here, negative c is the smaller number, 3 is the larger number, so we're going to add c to both sides of the equation. And we're left with negative 7 is equal to 3 c's plus another c gives us 4c plus 5. Then we're going to subtract 5 from both sides of the equation. And that leaves us with negative 12 equals 4c. 4 multiplied by c, and then we're going to divide by 4 on both sides of the equation to find out what c is. So 4c divided by 4 is 1c. Negative 12 divided by 4 is negative 3. Number 11, we have 4g equals 10g minus 6. Well, 4g is smaller than 10g, so I'm going to move 4g by subtracting it from both sides of the equation. And that leaves 0 equals 10g minus 4g is 6g minus 6. Then we're going to add 6 to both sides of the equation. And that leaves us with 6 equals 6g. Well, 6g is the same as saying 6 multiplied by g, so we're going to divide by 6 on both sides of the equation. Therefore, g has to be 1. Let's look at number 12. We have negative 7k minus 5 plus k is equal to negative 5 minus 4k. So again, because we have 3 terms on the left side of the equal sign, we want to simplify that first by combining like terms. We have negative 7k, and then we have positive k. Those are 2 terms that are alike. So basically what I just did was group them together. So negative 7k plus k, negative 7 has the advantage by 6, so we're going to put negative 6k minus 5 is equal to negative 5 minus 4k. Now, 6, or the absolute value of negative 6, is the greatest number, so we're going to add 6k to both sides of the equation, so we have a positive algebraic term. We have negative 5 is equal to negative 5 plus 2k. And now we're going to add 5 to both sides of the equation. And negative 5 plus 5 equals 0. And then we have 2k on the right side of the equation. We're going to divide both sides of the equation by 2. 2k divided by 2 leaves us with a positive k. 0 divided by 2 leaves us with 0. Let's go ahead and look at number 13. So we have 6t minus 19 is equal to 3t plus 20. 3 is smaller than 6, so we're going to subtract 3t from both sides of the equation. And that leaves us with 3t minus 19 is equal to 20. Then we're going to add 19 to both sides of the equation. And we're left with 3t is equal to 39. 3 multiplied by t equals 39, so we're going to divide by 3 on both sides of the equation. 3t divided by 3 leaves us with t. 39 divided by 3 leaves us with 13. All right, I hope you will go on to finish with these. Even though you have the decimals, the process is exactly the same. I'll see you next time.